Greetings, Soulswind here, and welcome to Let's Play Infinifactory. This is the Resistance campaign. We're on Atropos Station, and the puzzle name is Control Console. And I think now we're at a different level. So it's basically Hangar 5 now, and we were at Hangar 9, even though I didn't really point it out the last puzzle. But the production zone planet supposedly has moved. Like, you know, we were looking at it like this and now like this, maybe because we're on a higher level, but then again, it's not possible that the change is so drastic. Like, you know, the angle, I guess it's in orbit and it has moved a little bit. Regardless, we need to submit this. And we're given the component pieces like that. These. With reference to these, so the levers and whatnot, and then this connecting piece in the middle. And also we're given this, which means we have to remove some of these pieces in the middle. So this is my solution 1. The input rate is 0. I'm just going to show how it works without explaining. And of course, we're able to improve it by optimizing some of these places, like remove some of these conveyor belts here, and maybe here, like this, and also some of these. But then again, it's just gonna save us like maybe 30 blocks at most. This is not efficient. Input rate 0 is never too good, so well, we'll just see. So it drops there, goes in there, goes over there. So that's the first one over here. This is the first one actually. So it goes there. And the thing is that when the first one reaches there, this set from the first one just gets released and gets sent over here to be welded like that. So it moves along, but you see there's no anything to tell this to move. Instead, it's being moved by this one that comes in here, because it's just timed to like go in there and get submitted. Actually, it's not really. I think I could have done something here instead, but it's fine because eventually having these come over here, like these tell this to move, may not be so good, because, you know, like this is lesser blocks than just having something get sent all the way from there, have a conduit come over here. Not so good. Instead, this is way simpler and should be used like that. So yeah, so let's just see. And of course the time delay here really bad, but well, yeah, this is like a really interesting factory, isn't it? Like, you know, like this is like how factories should look like. Not optimized, you know. Well, anyways, of course optimizing is good. It saves a lot of costs and whatnot. But yeah, seeing all these pieces move like that, you know, just so cool and so fulfilling. So timely, huh? Just move into place, drops in place just in time, and those also, you see? Yeah, just in time. Yeah, see that? And that's it. That's our score right here. So cycle score average, so it's not that bad. Footprint score obviously terrible, because, you know, all these things like moving around, and especially the time delay for the single pieces and whatnot. The block score is also bad. Like, you know, we can reduce about 30 to give us like 210 or maybe 200 something. That will put us around here, which is still below average. Same for the footprint. So see you back here in solution 2. And this is solution 2. It may look pretty complicated as well, but you can see that the blocks are way lesser at 100 plus. I think previously it was like 200 or something. And yeah, now it's 100 plus. And you see here, no more elaborate time delays, just because like these are singular pieces, so we still have to depend on a lot of these conveyor belts to send them across. But this is already way more optimal. And with these pieces coming in, like, they're different pieces and yet they share the same conveyor belt. That is a lot of savings. So that goes there. Okay, these making use of these timers, we use the same eviscerator or the same set of eviscerators to do the cutting. See? Just in time. So that one, this dropping piece blocking that one, I can't seem to find a way to prevent this from happening, unfortunately. You know, like, it just happens and there's nothing I can do to stop this thing from happening. Like, if it goes sooner, this doesn't reach in time. If it goes later, then it will get blocked by this one. So regardless, someone has to wait for the other one. So yeah, maybe though, maybe I can just move this forward over here, like, you know, have it wait over there instead. But yeah, we need something to give it momentum, so it's okay. And that's it. So it's really simple, like, you know, over here, okay, let's see. I need to know which is the first one, so we'll restart that, okay? So basically this counts like 2 first, and then this counts like this counts 4, this counts 6. Okay, so when it's like 2, it's okay. When it's 4, it gets pushed over to this side to remove the middle piece over there, and this is 6, so this gets moved even further over to here to get the corner piece cut. And when it moves forward, this sensor then triggers this one to come in to cut this bottom piece as well, so entirely cut and gets moved along. And this is where it encounters this piece to block the place. So anyways, the first few pieces goes here, like the first one goes here, gets here and waits for these two to drop in. This one comes in here and just waits around there. Maybe, just maybe, I could have sent it over there and, like, you know, have it fall in there, but, you know, it's fine because it has to vacate its position for the new pieces that are coming in, so it has to move along, which is why it comes here instead and, you know, kind of blocks that one from moving, this one over here. So I tried fine-tuning, I couldn't really do much, but anyway, cycle score should be better because it's like +2, so yeah, should be better. And yes, we need to weld that one too, so that's how it's welded. Because if you put it in place, as long as it's, like, you know, lateral, then it's able to like weld it. If it's like vertical or something, then it moves out of place. So only direction that will dislodge this is if it moves this way, like towards the submission. So that's that, and that's how it works here. So I'm pretty satisfied with this result, and I hope we do get a much better score. This is the last submission. Da-da-da-dun. And yeah, we do get way better cycle score. Now it's way above average, 196, not the best yet. The footprint score also improved drastically to above average from below average, and block score also from below average to above average, so pretty good. And that's it. That's the solution. Like I always say, this is not the best, and there can be improvement, so let me know how I can tweak this, especially if I could just prevent this thing from blocking the one that's moving over and still have this like fall in place and be welded. So let me know. Otherwise, that's it. I'll meet you back here in the next episode. That's all I have for now. Have a nice day.